Lesson 9.2 is problems involving quadratics. Here is a list of the three main forms of a quadratic function and how to find all the different pieces. So I would pause the video and write down these notes. So the first one is the general form, which they give you on your formula booklet, and that's f of x equals ax squared plus bx plus c, also sometimes called standard form, where a, b, and c are real numbers and a can't be 0. That's true for everything. So given this, the vertex would be opposite of b divided by 2 times a, and the y-coordinate of the vertex, you would plug that back in what you got for x and solve for y, and that's your y-coordinate of your vertex. Your axis of symmetry, which they give you on the formula booklet, is x is equal to the x-coordinate of the vertex, so negative b over 2a. For your intercepts, your x-intercepts, you would set this thing equal to 0 and solve either by factoring, completing the square, quadratic formula, or graphing calculator. The y-intercept, you plug in 0, everything with an x goes away, and you're left with just the c. So that's the y-intercept for in standard form. The next one is vertex form, which they don't really talk about much in IB, but it's something that we've focused in previous math classes, so that's why I put it on here. And that is f of x equals a times x minus h quantity squared plus k. You can go from standard or general form to vertex form by completing the square. It's really nice because then you can read off the vertex as hk. And the axis of symmetry, again, is x equals the x-coordinate of the vertex, or h. Your x-intercepts, you would set this thing equal to 0, and then you'd solve. It's already completed the square, so you would just solve for x. And the y-intercept, you'd plug in 0 for x and simplify. Intercept form, f of x is equal to a times x minus m times x minus n. You could go from general form to intercept form by factoring, if it factors nicely, where m and n are your x-intercepts. So the vertex is halfway in between the two x-intercepts, the x-coordinate. So if you take the average of the two x-intercepts, that's going to be the x-coordinate of your vertex. And then if you plug those back in for x, you solve for y, that's the y-coordinate of your vertex. Axis of symmetry, x is equal to the average of the two x-intercepts, or the x-coordinate of your vertex. The x-intercepts, so if you set this thing equal to 0, y equals 0, you have 0 product property, so your x-intercepts are whatever those two values are. And then your y-intercepts, just plug in 0 and solve. So all three forms are useful just depending on what you're doing, but it's nice to be able to, no matter what form you're in, find the different pieces of information without having to switch between the forms. So here we have a rectangular mirror that has a perimeter of 260 centimeters. We're deciding that we're going to call the length of this mirror x. So for part A, we want to find the height of the mirror in terms of x. And then once you've done that, for part B, we want to find an equation for the area of the mirror in terms of x. So go ahead and pause the video and do parts A and B. So for part A, I used the perimeter equation to help us find the height in terms of x. So the perimeter of a rectangle is twice the length plus twice the height, and we're calling the length x. And I set this thing equal to 260 because they told us that's what the perimeter was. So then I solved this for h. I subtracted 2x from both sides and divided everything by 2. So the height is 130 minus whatever x is. So then the area is length times height, or length times width, and the length is x, and the height is 130 minus x. So the area of the rectangle in terms of x is x times 130 minus x. So now you're going to use your graphing calculator to plot your equation for area of the mirror with area on the y-axis and length x on the x-axis, choosing a suitable domain and range. And then using that graph, you're going to find the coordinates for which the graph intersects the x-axis, state what those values of x represent, and then find an equation for the graph's line of symmetry and state whether the equation of the line of symmetry or what it tells you in this context. So go ahead and pause the video and do parts C through G. So I used my graphing calculator to help me sketch a graph here. So I scaled the length down here on the x and the area on the y. And I found the key points here. I found the intercepts and I found the vertex. So the coordinates for the x, where they intercept the x-axis, it's 0, 0, and 130, 0, because that's where it makes this equal to 0. And what does that mean? So when the length is 0 centimeters or 130 centimeters, the area will be 0 centimeters because the one side won't exist, so you can't really have a mirror. Find the equation for the axis of symmetry. It's the average between the two x-intercepts, so 0 plus 130 over 2. Remember, it's an equation, so it's x equals 65. And then what does that mean? That means that at x equals 65, you have your maximum area, and then the x values between 0 and 65 are symmetric to the ones between 65 and 130. So the area is symmetric on either side of that x equals 65 centimeters. So for this next example, we have the side view of a suspension bridge that's being modeled by the equation f of x is equal to 0.000972 x squared minus 1.167x, where x is the horizontal distance in meters and f of x is the depth of the bridge in meters. So first we want to plot the graph. You can use your graphing calculator to help you sketch a graph of this. And then using that and using your graphing calculator, we want to find the coordinates where the graph crosses the x-axis, use those values to write the axis of symmetry, and use your answer in part B to find the y-coordinate of the minimum, and then describe what that minimum point represents. So go ahead and pause the video and try this one. So I graphed this on my graphing calculator and then copied the sketch over here using my zeros and my minimum value. So then the coordinates of the x-intercepts are 0, 0, and 1200, 0. And using those values to find the axis of symmetry, I found the average between the two x-intercepts as 0 plus 1200 over 2 is 600. So our axis of symmetry is x equals 600. Using that information to find the y-coordinate of the vertex, so this is going to be the x-coordinate of your vertex or the x-coordinate of your minimum value. So I took that and I plugged that in for x in f of x and got the y-coordinate of the minimum to be negative 350 meters. And this is the lowest depth of the suspension bridge for the whole bridge. Here's another example where Patrick tries to kick a rugby ball over the crossbar of a goal. A lot of ball motions, projectile motion, they're represented with parabolas and quadratic functions. The feet of the goalposts are 13 meters away from where he kicks the ball, and the vertical height of the ball in meters is approximately modeled by the function f of x is equal to negative 0.1x squared plus 1.5x, where x is the horizontal distance from where the ball was kicked. So using that and any of the different forms of our equations, find the maximum height of the rugby ball, find the coordinates of the y-intercept and explain what that tells you from where Patrick kicked the ball, and then given that the crossbar is 2.5 meters above the ground, determine whether or not the ball passes over the crossbar and justify your answer. So go ahead and pause the video and try this one. So for this one, I used the general form way to find the vertex. So I found the x-coordinate of the vertex, or the maximum, because the maximum occurs at the vertex, which is negative b over 2a, and b is 1.5 and a is negative 0.1. So the x-coordinate of the vertex occurs at 7.5, so 7.5 meters away from where he kicks the ball, it will be at its maximum. So then to find the actual maximum height, I plugged that in for x into our function and found that the maximum height was 5.625 meters off the ground. For part B, find the y-coordinate, or coordinates of the y-coordinate. So I plugged in 0 for x and I got 0 meters. So the coordinate, if you write it as coordinate point, would be 0, 0. And what this means is that when he kicks the ball, it's sitting on the ground. It doesn't have any initial height. For part C, given that the crossbar is 2.5 meters above the ground, determine whether or not it'll pass the crossbar. Well, I used the fact that he's 13 meters away from the goalpost, so I wanted to figure out the height of the ball at that 13 meters. So I plugged 13 into the function to figure out the height, and I found that 13 meters away from where he kicks the ball, it will be 2.6 meters above the ground. And since that's above the goalpost of 2.5 meters, he should make it over the crossbar. The height of the ball at that point is higher than the crossbar, so therefore he should make it. For this next example, we have the function f of x equals 4 times x minus 5 times x plus 3. So here's a quadratic equation that's in intercept form. So using this information, find the x-intercepts, find the equation of the axis of symmetry, find the coordinates of the vertex, and then using all that information, then graph the function. Use your graphing calculator only to check your final answer. So go ahead and pause the video and try this one. This function is in intercept form, so in order to find the x-intercepts, you just set it equal to 0, and then it's already factored, so zero product property, just set each of the factors equal to 0. So you have x minus 5 is equal to 0, so one of the x-intercepts is 5, 0, and then x plus 3 equals 0, so the other x-intercept, that should say, is negative 3, 0. So those are your x-intercepts when you're in factored form. And then the next one, it's asking for the axis symmetry, so I just found the average between these two, so x is equal to 5 plus negative 3 over 2, so your axis symmetry is a positive 1. And then find the coordinates of the vertex. If your axis symmetry is positive 1, that is your x coordinate of your vertex, so I plugged that in for x to find the y coordinate of the vertex, and I got the y coordinate was negative 64. So the coordinates of the vertex are 1, negative 64. And then just to help me with my graph, I also found the y-intercept. So I plugged in 0 for x, and I found the y-intercept to be negative 60. So to graph this thing, I have my vertex at 1, negative 64. I have x-intercepts at negative 3 and positive 5. I have a y-intercept at y equals negative 60, which means by symmetry, I also have this point here at 2, negative 60, and then I use that to sketch my graph. So that's how you would do this if it was in intercept form. This next example, we have the function f of x is equal to negative 2x squared plus 8x plus 24, and we want to graph this without a graphing calculator, showing the x and y intercepts and the coordinates of the max or min point. So I would find those pieces of information first and use them to help you graph this. So go ahead and pause the video and sketch a graph of this function. So the first thing I did is I found my x-intercept, so I set this equal to 0, set the whole function equal to 0, and then I factored it. I took a negative 2 out of everything, and then x squared minus 4x minus 12 factors into x minus 6 times x plus 2. So this is the factored form, or the intercept form of this quadratic function, this parabola. And so if you use zero product property, you find that your x-intercepts are x equals 6 and negative 2, or 6, 0, negative 2, 0. So I plotted those two. And then our y-intercept, when you're in standard form, the y-intercept is just your c value, because when you plug in 0 for x, anything with an x goes away. So our y-intercept is 24, or 0, 24, so I plotted that. And then the vertex, I found the x-coordinate of the vertex by doing negative b over 2a, so negative 8 divided by 2 times negative 2. So the x-coordinate of our vertex is 2. You could have also found the average between your x-intercepts, which would have given you the same thing. And then I plugged that back in for x to find my y value. So the y value of our vertex, which happens to be a maximum point, is 32. So our vertex is 232. So I plotted that. I also plotted this point, which is the symmetrical line of 0, 24. So therefore it was at this point over here. And therefore I graphed this function. And since it's facing down, our a value is negative, our vertex is going to be a maximum point. The last part of this section is to write the equation of a given curve based on either information or a graph. And there's two methods that we're going to be talking about. One is using your graphing calculator's quadratic regression function, and the other one is using the simultaneous equation solver on your graphing calculator. So for this one, we have a parabola. We have a graph of a parabola, and we're going to use this to write the equation of the curve. So first thing that we're going to do is we're going to find the coordinates of the x and y intercepts. So go ahead and pause the video and find the coordinates of the x and y intercepts. So for the x-intercepts, our coordinates are negative 4, 0, and 2, 0, and for our y-intercept, our coordinate is 0, negative 12. So the first method is to use the quadratic regression on your graphing calculator, similar to how we've done linear regressions in the past. So you're going to go into Stat, you're going to go to Edit, and L1, you're going to list all of your x values, so negative 4, 2, and 0. And then L2, you're going to list the corresponding y values. Make sure you match them up. So whatever line you have negative 4 on, the y value in list 2 should be 0, 2, 0, and 0, negative 12. So you should have those 3 points. Once you have those 3 points in your table, you go to Stat, Calc, and then we want to go to number 5, Quadratic Regression. Make sure your x list is list 1, make sure your y list is list 2, and then hit Calculate, and it should give you your a, b, and c values. So it's not a great picture, but here I have a little picture of my final quadratic regression screen. So they have y equals ax squared plus bx plus c, where a is 1.5, b is 3, and c is negative 12. So our function, f of x, is going to be 1.5x squared plus 3x minus 12. So that's the method using your quadratic regression. So you need to have at least 3 points. In this case, we had the two x-intercepts and the y-intercept. You could also use the vertex if it's easy to see. This one is not very easy to read off, so it's not going to give you a good number. But if it's something that's easy to read, you could also throw the vertex in there. The second method is to use a system of equations. So what you're going to do is you're going to plug these 3 points in and basically create a system of 3 equations with the 3 unknowns. But the first one gets solved right away. So when you plug in your y-intercept, you're plugging it into the general form of a parabola, which is f of x is equal to ax squared plus bx plus c. So if I plug in 0 for x, everything goes away except for our c value. So that means our c value has to be negative 12, because our c value is always our y-intercept. So then I also plugged in negative 4. We don't know a, so we have a times negative 4 squared plus b times negative 4 minus the c value we just found of 12 is equal to the y-coordinate in negative 4, which is 0. So now we have an equation 16a minus 4b is equal to 12. And I did the same thing with 2, 0. I plugged in 0 for x, so a times 2 squared plus b times 2 minus 12 is equal to 0. So therefore 4a plus 2b is equal to 12. So now that you have these two equations, you're going to go into apps and go to number 9, which is the polysomalt 2. You're going to go to the second one, the simultaneous equation solver. In this case, our equations and our unknown are both 2, so you don't really need to change anything. Hit graph to go to the next button, and then you're going to enter the two equations. In this case, they call them x and y, but a is what they're calling x and b is what they're calling y, and then you're going to hit solve. So then once you solve, you'll get x equals a number and y equals a number. That x is your a value, so x was 3/2 or 1.5, and that y is your b value. So then you can read those off and you get the same function that we found with c being negative 12. So f of x equals 1.5x squared plus 3x minus 12. So that's two different methods to use your graphing calculator in order to find the equation of a parabola based on 3 points. You have to have at least 3 points, whether it be 2 x-intercepts and a y-intercept, or a vertex, or whatever 3 points you can read off. So this has been problems involving quadratics, including writing equations of quadratics and using equations of quadratics to model.